In this lecture, we will be studying about equivalence of two finite automata, which means that given two finite automata, how do you recognize or how do you identify whether these two given finite automata are the same or not? And what do we mean by same or equivalent? By same or equivalent, we mean that the two automatas perform the same kind of function. That means the languages they accept will be the same. So that is what we are going to study. And in order to identify whether two automata are equivalent or not, there are certain steps that you need to follow in order to identify them. So first, let us see what are those steps. So here are the steps that are required to identify the equivalences. So the first step is, for any pair of states qi and qj, the transition for input a belongs to sigma is defined by qa qb, where the transition from qi on a goes to qa and the transition from qj on a goes to qb. The two automata are not equivalent if for a pair qa-qb, one is intermediate state and the other is final state. So what we mean by this is that, suppose we have two automatas, and from the two automatas we select pairs of states, one from the first automata, the other from the second automata, and let's say we get a pair qi-qj, and then let's say we have an input a which is there in both the automatas, and we will see the transition of these pairs on getting the input a. That means, where does this qi from the first automata go to on getting input a, and where does the state qj from the second automata go to on getting this particular input a. And let's say that qi goes to qa and qj goes to qb on getting this input a in both the automatas. And then if qa and qb are both final states or both non-final states or intermediate states, then we can say that the two automatas are equivalent. That means when you get this pair qa-qb, if you see that both qa and qb are either final states or either non-final states, then the two automatas are equivalent. But if you see that qa is an intermediate state, that means qa is a non-final state and qb is a final state, that means if one is a intermediate state and the other one is a final state, then the two automata are not equivalent. So that is what these steps are trying to tell us. So this will become more clear when we take example. And then the second step says that if initial state is final state of one automata, then in second automaton also initial state must be final state for them to be equivalent. That means in the first automata, if its initial state and final state is the same state, then even in the second automata, its initial state and final state should be the same for them to be equivalent. Otherwise, they will not be equivalent. So let us take a simple example to understand this in a better way. Okay, so here we have an example where we have two automata. This is the first automaton and this is the second automaton. So let me call them by names. Let me say that this is A and this is automaton B. So in order to check whether these two automata are equivalent or not, I will make a table over here, where here I will write the states, where I'll make the pairs of states over here. And if you notice in this automata, the inputs are C and D. So here I'll write for input C and here I'll write for input D. Okay, so if you notice that in automata A and B, in A the initial state is Q1 and the final state is also Q1. And even in this automaton number B, Q4 is the initial state as well as the final state. So here also the initial state and the final state is the same. So we satisfy this second condition already, where it says that if the initial state is final state in one of them, it should be the same for the other as well. So since in both of them the initial state and final states are same, so the second condition is already satisfied. Now let's check the first condition. So for that we have to make pairs of states. So here let's make the first pair as Q1 and Q4. Since they are the initial states, let me make a pair like that, Q1, Q4. So we have to see where does this Q1 and Q4 go on getting inputs C and D. So let's see, Q1 on input C. Q1 on input C goes to Q1 itself, and Q4 on input C goes to Q4 itself. So here we get a pair of state Q1, Q4, and check if Q1 and Q4 are final states or intermediate states. So we see that Q1 is a final state and Q4 here it is also a final state. So let me just write Fs to just represent it as a final state. So both of them are final states. Okay, now let's do for input D. Q1 on input D goes to Q2, and Q4 on input D goes to Q5. And let's check if they are final states or intermediate states. So if you see, Q2 is a non-final state or intermediate state. So let me write IS just to denote intermediate state. And Q5 is also an intermediate state. So we see that this pair both are final states, and in this pair both are intermediate states. So this was the condition that we wanted. This is the condition that was mentioned in step 1. If both of them are final states or if both of them are intermediate states, then we can say that they are equivalent. But if one is a final state and the other is an intermediate state, then they cannot be called equivalent. Okay, but this is not complete because we have only checked for one pair. We have to check for all the pairs of states. Alright, now let's check for the pairs Q2 and Q5. Q2, Q5. If you check for Q2, Q5, Q2 on input C goes to Q3, and Q5 on input C goes to Q6. You can check it in the diagram. And if you see that Q3 is an intermediate state and Q6 is also an intermediate state over here. And let's do the same thing for input D. Q2 on input D goes to Q1, and Q5 on input D goes to Q4. And if you check, you can find that Q1 and Q4 both are final states. So here we again get pairs which are same. Either they are both intermediate or either they are both final states. So far they are equivalent. Now we have to check for the next pair of state, which will be Q3 and Q6. Q3, Q6. So if you check for Q3, Q6, we see that Q3 on input C goes to Q2, and Q6 on input C goes to Q7. And let's see whether they are intermediate states or final states. Q2 is a intermediate state, IS, and Q7 is also an intermediate state. Alright, now let's do the same thing for input D. Q3, this Q3 on input D goes to Q3 itself, and Q6 on input D goes to Q6 itself. You can check it in the diagram, and we see that both Q3 and Q6 are also intermediate states. So far also all the pairs that we got are either both intermediate states or both final states. So till now it is equivalent. Now if you see that we have compared Q1 and Q4, Q2 and Q5, Q3 and Q6, but Q7 is left, and we see that Q2, Q7 is a new pair of state that has been formed in this table. So you have to check for the pair Q2, Q7. So let us check for this pair. If you check for this pair, we see that Q2 on input C goes to Q3, and Q7 on input C goes to Q6. And if you see, Q3 is an intermediate state and Q6 also is an intermediate state. So I'll write IS. And then on input D, where do they go? They go to Q1, Q4. And Q1 and Q4, if you check in our diagram, Q1 and Q4 are both final states. So these two are also final state. Okay. So now you see that for all the pairs that we have checked, the transitions or the pairs of state that we get on inputs C and D are both final states or both intermediate states. Here final state, here intermediate state. So we see that all the pairs are the same kind, either they are final state or intermediate state. So if you find that all the pairs are either final state or intermediate state, then we can say that the automata A and B are equivalent. Now when you are checking, if you find that if in any of the pairs one is a final state and another is a intermediate state, then at that moment you can stop the checking and confirm that they are not equivalent. But from this example we found that both these automata are equivalent. So this is the steps that we followed, and I hope it is clear to you. By taking